Welcome all. In this video I am going to present about the bypass governing system and energy losses in steam turbines. Bypass governing, occasionally the turbine is overloaded for short duration. During such operation, bypass valves are opened and fresh steam is introduced into the later stages of the turbine. This generates more energy to satisfy the increased load. The schematic of bypass governing is as shown in figure 3. This is bypass governing system. We can see the bypass valve at the top of the governing system where the bypass steam is entry and exit place regions are there, and then throttle valve also located at bottom of this bypass valve. The nozzle diaphragm is located at the right hand side and the main valve is located at the bottommost left hand side. The bypass governing, the total amount of steam entering the turbine passes through the valve A, which is under the control of speed governor. The throttling valve represented as A and the bypass valve represented as B. The B is the nozzle box or steam chest. Here the B is represented as steam chest. For all loads greater than the economic load, a bypass valve C is open, allowing steam to pass from the first stage nozzle box into the steam belt D and so into the nozzle of downstream stage. The valve C is designed such that it is not open until the lift of the valve A diminishes. The bypass valve C remains under control of a speed governor for all loads within its range. And also in the session going to discuss about energy losses in steam turbine. There are different losses are there. In the next video I am going to show what are the different types of external losses will be. In this session I will explain about common energy losses. Increase in heat energy required for doing mechanical work in actual practice as compared to the theoretical value is termed as energy loss. The losses which appear in an actual turbine may be divided into two following steps or groups. First one is the internal losses. The losses directly connected with the steam condition while in its flow through turbine. First one, losses in regulating valves. Second one, losses in nozzle, which means the guide plates will leads to that losses. Third one, losses in moving blade, and A, the losses due to trailing edge wake. B, impingement losses. C, losses due to leakage of steam through the annular space. The frictional loss is also one of the another important losses. The losses due to turning of the steam jet in the plates. Losses due to shrouding, leaving velocity losses, which means this is one of the exit velocity. Losses due to friction of disc carrying the blades and windage losses. Losses due to clearance between the rotor and guide blade discs. Losses due to clearance between the rotor and the guide blade discs, and losses in exhaust piping, etc. And some more losses also will be in that internal related losses. Here the external losses also possible to do that steam turbine process. Losses which don't influence the steam condition, they may be further classified as A. Mechanical losses, B. Losses due to leakage of steam from gland seal, which means where the governing system will provide or else will absorb some amount of energy when it is operating or controlling the steam supplying system. Because of that, the mechanical losses will be there. Also, the bearing and some other rotary part and sliding parts will leads to provide that mechanical loss. Loss due to leakage of steam means in the joints, the steam line joints will provide some more frictional loss due to their joints, like gland seal is also one of the obstruction while flowing the steam into the steam tube, so that there will be some losses, but these losses not too much than friction loss, so that these all are the secondary losses. So the external losses also accumulate according the requirement or condition, but these losses will be very few amount compared with that friction loss. Thank you for watching this video. We will continue in that next video.